Dear audience, now I want to show you how the unique features of the high-resolution cyclic ion mobility can be utilized for shotgun lipidomics. In the shotgun lipidomics, we have the scenario that lipids from a total lipid extract are ionized together, and some of the lipids have a similar or the same MC. We want to separate those lipid analytes by ion mobility to obtain selective and specific fragment spectra to achieve an unequivocal assignment of the shared fragments. This should enhance the specificity and the quantification accuracy compared to the classical approach. The unique features of the cyclic ion mobility that we can use are that we have first effective transfer of the ions to the vacuum, which should give us sensitive measurements. We can adjust the resolving power of the ion mobility by the number of passes to the experimental needs. And we cannot separate only the precursor by mobility and mass to charge ratio, but also the specific fragments. One example for ion mobility separation of isobaric species is shown here in this slide, where we have the phosphatidylserine 17017 and the phosphatidylcholine 14117, which are, as you see here, after 5 passes baseline separated, and we can unequivocally assign the shared fragment to both of them, which is an advantage for the quantification accuracy. Now, we can also use for the cyclic ion mobility the ion mobility MSN option. And what we've done here is we selected the triacylglycerol species 48.1 from a total bovine heart extract and subjected the ammonium adduct to collision-induced dissociation, by which we get several neutral losses after 5 passes baseline separated. So we have here neutral losses, which are different by 1 double bond, baseline separated. And we can now isolate one of these neutral losses and subject this to further ion mobility separation, by which we get, for instance, here the neutral losses with the fatty acid 14.0 and 18.0 peak separated from the diacylglycerol with fatty acid 16.0, 16.0. The take-home message of the poster is that high-resolution cyclic ion mobility extends the toolbox of the tandem mass spectrometry and enhances by this the specificity and the quantification accuracy of the shotgun lipidomics. Plus, we have the capability to get enhanced structural characterization for lipid analytes.